All right, class, I've had a couple of people ask some questions about the empirical rule and z-scores, so I thought I'd just put together a quick video to talk through a couple of these things and explain how they work and show you what you'll see in the quizzes. So first thing, so the empirical rule it's all about like how much of your data set is within like a given range of values. Or it really kind of talks about like how when you collect a bunch of data, it's a rule for understanding how that data is distributed across the distribution. Now, one of the most important things here when you're dealing with the empirical rule is that your distribution has to be normal. Okay, so we have here on the screen a normal distribution, right? The distribution has got to be normal for this to work. And the reason why it has to be normal is because, number one, normal distributions are symmetrical, and number two, not only are they symmetrical, but they're proportioned the right way for the empirical rule to work, right? The empirical rule is based on the proportions of these normal distributions. So really, like a condition to being able to use the empirical rule is that you have to have a distribution that is close to normal, okay? And I think most of the problems that we deal with mention whether or not the distributions we're using are close to normal. And if they do, right, if they say, hey, you've collected this data, you've plotted it, and you can see that it creates a normal distribution, you know that you're probably going to use the ideas that are hiding inside the empirical rule to answer this. So a couple of things. First is a distribution like this, right? We know right here in the middle well, that's supposed to be the middle. Anyway, so right there in the middle, right, that's where the mean is, okay? And for a distribution that's normal, the mean, median, and mode are all in the same place. So all of those things are sitting right here. And then what they do for this is they say, okay, the other thing that we've been talking about is standard deviation. And you say, okay, so I have this distribution. I know that it's normal. Here's the center. I know that this is where the mean, median, and mode are. So the standard deviation kind of tells you how well that data is distributed around the mean. Okay, so for distributions like this, you'll find you have one standard deviation on either side. Okay, so for example, this would be like this is your positive one. This is your minus one, right? So everything over here, well, this value right here is exactly one standard deviation above the mean, and this value right here is exactly one standard deviation below the mean, hence the negative, right? And then you've got two standard deviations below the mean, two standard deviations above the mean, and then out here, three standard deviations below, three standard deviations above. Okay. Anyways, so we can mark out where the standard deviations are with respect to the mean and over this thing. Okay, so that's kind of the first thing to do when you're looking at this. But the really nice thing about looking at these standard deviations is that it cuts up the distribution really cleanly into some well-proportioned pieces, okay? So, for example, everything in here, right, all of this is exactly, it's within one standard deviation of the mean, either to the left or to the right. Everything here, all of that is within two standard deviations of the mean, okay? And then I could step out even further, right? And I could go, and I could say all of that, right, is within three standard deviations of the mean, right? And that's basically all the distribution, almost all of it. The only thing that we're missing is this little teeny tiny bit on either end, just a teeny tiny fraction. But the really cool thing about the empirical rule is that what it tells you is that almost all of your data is hiding within three standard deviations of the mean, one way or the other, right? Basically, all the data is sitting in that spot, okay? So clean this up a little bit. So what exactly are these proportions? Because that's what the empirical rule is the empirical rule says, hey, we have these things, and we know what these proportions are, right? So here's one standard deviation, right? -1 and +1. and so I know that between here and here, you will find 68% of all of the data you've collected is going to be hiding within that one standard deviation. And if we hop out to 2 standard deviations, so there's -2 and +2, then in between 2 standard deviations, that's 95% of all of your data is within 2 standard deviations of the mean. And then finally, if we go all the way out to -3 and +3, between those two values, we have 99.7%, right? Basically everything but 0.3, right? And so of your data is hiding between those 3 standard deviations. And so we know those exact proportions. And that's the beauty of the empirical rule, is it tells us all these really cool things. So let's scoot on. So now here's the empirical rule written really nicely. My handwriting is not as good as this typed up stuff. But just to kind of show you, right, here's our mean again. This is the mean +1 standard deviation, the mean +2, the mean +3, the mean -1, the mean -2, the mean -3 standard deviations. Okay? And then it shows, right, there's our percentages, again, from the empirical rule. But the one nice thing that this slide shows us is exactly how much, right, this 68, I could divide it in half, and that's 34 and 34. This 95, which is all of this, so it's the 68 plus a little bit on each side. Well, that little bit on each side is 13 and a half. And then hiding in this last little bit is 2.4%, right? So those percentages are nice. It's a nice thing to kind of have on hand when you're dealing with the empirical rule, okay? So for example, I could ask you a question. I could say, hey, how much, let's say you've collected a bunch of data, and I want to know how much of the distribution, or how much of the data you collected is less than or is below 1 standard deviation of the data you've collected. So you'd look at this and you'd be like, okay, below 1 standard deviation. Well, here's my -1 standard deviations, and I want to know, okay, well, what's everything that's below that? Okay, well, then I could go over here and I could say, well, I have 13.5 and 2.4, and I could add those together. So that's 15.7%, right? So that's telling me that if I know what this -1 standard deviation is, I know that 15.7% of all of my data is going to be below that value. And on the flip side of that, I know that 68% plus this, right? All of this, that percent is above 1 standard deviation. Okay. So you'll see problems that ask you how much of your data is above or below a given standard deviation, and to figure those out. So okay, I'm going to make up some numbers here, and this can be dangerous because. Okay, well, let's say this. Let's say we collect some data, and after my data I collected, let's say and these are population values, but let's say that the mean of the population is, I don't know, let's say we're collecting data on, my go-to is hours of sleep. Let's say that the average hours of sleep is 7 hours of sleep, and let's say that the standard deviation for this is, so the amount that it varies, let's say that it varies by, again, I'm just making numbers up. Let's just do 1. The standard deviation is 1 hour, okay? So with those two pieces of information, there's a ton that I can do. So I can ask you, all right, if I wanted to know how much of your data, like between what two values is 95% of your data? Okay, so you've collected all this stuff, you found these things, and you want to know, okay, between what two values is 95% of the data? Well, I know from the empirical rule that that 95% of my data lies between -2 standard deviations and +2 standard deviations. Okay, so well, what values is that? Well, if my mean is 7 and if my standard deviation is 1, okay, well then 2 standard deviations, right? 2 standard deviations is just going to be 2 hours. So this value here, so if the mean is 7, then that means that, well, +1, right? Because this would be 7 + 1, so this would be 8, and +2 would be 9, and this would be 6, and this would be 5. So I could say that, okay, that between 5 and 9 hours of sleep, right? So I'm looking between the two different standard deviations. Between 5 and 9 hours of sleep, 95% of the people said that they were getting between 5 and 9 hours of sleep. And then you might get a question that asks, well, between what two values is basically all of the data? And anytime you see a question like that, you know that they're talking about this position right here, right? This position right here, that 99.7, that's basically all, right? How much between what two values is basically all of your data? Well, my average is 7, right? The mean is 7. And so over here, this is -3 standard deviations. So that's going to be 4 hours of sleep over here. And this is +3, so that's going to be 10. So what this means is that if these numbers are my actual values, what I'm saying is that almost everybody that I surveyed gave me an answer between 4 hours and 10 hours of sleep a night. That would include basically everyone that I surveyed. Now I just made these up. The real numbers would probably be more interesting than what I just said. But that's essentially how this works, and that's essentially how the empirical rule works. Is we're taking advantage of the fact that we have this really cool function that describes a population, and if I know what the standard deviation is, I can tell you a lot about the different percentages and where different amounts of things fit. Now, to take this like one step further, let's look at the Z-score. Okay, so I'm going to come back to the empirical rule in a second, but first I want to kind of talk about what the Z-score is. Okay, so what the Z-score is it's a way for me to kind of tell where a given value is in the distribution. Okay, so let's say here's my plot and here's my normal distribution. That's not very normal, but I mean that's as best as I can draw it. Normal distribution right there. Okay, anyways, if I go back to my sleep study, so the mean is 7 and I said that the standard deviation is 1. If I said, hey, let's say that somebody told me, oh, you know what, I only slept 8.5 hours, right? My average amount of sleep that I get a night is 8.5 hours. Where does that exactly fall in the distribution? Okay, well, you can find that out with the Z-score, okay? So with your Z-score, what you're going to do is you're going to say, all right, well, to calculate a Z-score, there's a pretty simple equation. Z is going to equal the data point that you're interested in minus the average, or the mean, divided by the standard deviation, okay? So for me, I'm going to say, okay, well, my data point is 8.5 minus the average, which is 7, divided by the standard deviation, which in our case is 1. And so 8.5 minus 7 is going to be 1.5, divided by 1 is 1.5, so 1.5. And the really cool thing about this is that this number is in units of standard deviations. So what you're saying is that this value, 8.5, it's 8.5 hours of sleep. That value is 1.5 standard deviations greater than the mean, greater than the average. So now if I pop back up to my graph over here, here's one standard deviation. Here's two standard deviations. The value I got was 1.5, right? So that's going to be right here in the middle. That what I'm saying is that value is right here in terms of my distribution, right here at this spot. And so that's the cool thing about the Z-score, is that it tells you exactly where you are in the distribution. And if I know that, I can make some guesses about approximately, how much stuff is below, how much of the data is below that value, right? Whatever all these percentages added up to be, that would be the amount that's below. But then the amount that's above is all of this stuff, right? What's the chance that somebody is sleeping more than 8.5 hours, right? Well, you can find that percentage in here on this side. So that's the really cool thing about the Z-score. Okay, so let me go, and then the other thing that other questions that you could see that relate to the Z-score might look like this, right? Somebody may say, hey, I know there may be a silly questionnaire that goes around that says, how many donuts do you eat a week? And let's say that the average amount of donuts that a population eats per week is 12 donuts per week. And let's say that the standard deviation is 2.5, right? So the average person eats 12 donuts a week, and then on average, the rest of the numbers in the data you collected varies by 2.5 donuts from the average. Okay, so with these two things, I can calculate a Z-score for any score, right? Somebody may say, hey, well, I only eat 3 donuts a week, so where am I in this distribution? And so then you would say, okay, well, that's easy to find. I would just say, okay, I'm going to do 3 minus 12 divided by 2.5. Sorry, my handwriting is getting sloppy. So you're looking at this and you'll be like, okay, well, this is going to be negative 9, and this is going to still be 2.5. So I've got a negative number, right? And so this is minus 3.6. And so what does that mean, right? That minus 3.6 says that, it's telling you the standard deviation. So now if this distribution is normal, and it probably wouldn't be, but let's pretend that it is, minus 3.6, well, here's your 1 standard deviation, 2, 3 was right here, 3.6 is going to be over here, right? And we already said that if you're using the empirical rule, 99.7% of all of your data is between minus 3 and 3. And here you are, so you have some person that's saying that they're eating 3. Well, that's minus 3.6 standard deviations away. So that number is way out here. So that number is really, really unlikely to be found within the study you made, because it's so small compared to the mean and the standard deviation. And this tells us that, right? It's outside of the realm that says, hey, we're well beyond what the normal range of data is for that thing. Okay, and so that's the really cool thing about Z-scores, is if you know what the Z-score is, it tells you a lot about how likely it is that you'll be able to find that number within the population you're studying. Okay, another thing that they could ask you about Z-scores, they could say. They could ask you the other way around. They could say, hey, I want to know what value, standard deviation of 5. I want to know what has a Z-score of 2 standard deviations, right? They could say, what has a value of 2 standard deviations? And then for that, you'd say, okay, well, I can do that too. So I'm going to say that 2 is going to be equal to the value that I'm looking for, minus 12 divided by the standard deviation, which is 5. And so I can now solve for that value, right? Multiply 5 by each side. So you have 10 equals x minus 12. Add 12 over, and so x here is going to be 22, right? So a value that's, again, here's my distribution. There's the mean. Here's one standard deviation. Here's two standard deviations. So a person... so people that claim to eat 22 donuts per week, they're right here. And what that means is that, right now between the two standard deviations, you have 95% of your data, right? 95% of your data live within that bounds, and the upper bound of that 95% is 22. Okay.